So in this lab, we observed a video of an object on a spring as it's released from rest. We recorded the position of the object over time in Tracker, and I'll play that for you now. So as you can see, the object is released and it starts doing this oscillating motion, and you can see in Tracker that it is oscillating. And you can see the auto tracker's point selection is always around the center of the object. And now that we have our data all recorded here, we needed to create a model of this system in GlowScript, which I'll show you now. And so if we go through the code, you'll see that we start off with the ball's mass of 0.4, and we have all these initial conditions that we set prior to the model running that are just based off of the values that are in this video. Um, then from here we calculate the spring constant, we calculated the relaxed length of the spring, and we calculated kinetic energy, the length that the spring is extended, all this, and then we calculate the force due to gravity, the force due to the spring, the net force, the change in the ball's position uh, over time, over each shift in time. And when I run this code, you'll see that we are able to put in our recorded data. So I'll put that in now. And we can compare it to the model as such. And so as you'll see, it's matching up, but the experiments data from the tracker video is a bit behind the model data, and this is due to but most likely due to some error in the code. I do not know GlowScript code super well. I do not know how to adjust these values properly, but we can see that they match up fairly well regardless. The only difference is this slight shift in the timing of both models. And as this comes to a close, let's discuss what this data means for us, what this data means to us, the physicists. And so we look at the model system and we ask ourselves, is the energy principle satisfied? And that's the principle that energy is neither created nor destroyed, but rather it changes forms. And when we look at the data here, the change in energy over time graph, we see, yes, absolutely, it does it does satisfy the energy principle, because the total energy, the total change in energy, remains zero throughout the entire model. And you'll see that the energy is changing forms from kinetic to potential, um, to the gravitational potential, the spring potential, and it all averages out to zero throughout the whole thing. So the energy principle is satisfied. And then looking at the data in Tracker, we can calculate that the period of motion in the x horizontal direction is about 1.65 seconds, and the period of motion in the y vertical direction is about 1.52. In theory, these two periods should be the same, and in observation, they're really close. So it's fair to say that this could easily be explained by a measurement error in the tracker. As you can see, it's not always precisely on the middle, even here perfectly. I accidentally went to a really good example of this, a really good frame, but the point is quite a bit off the center of the mass. And so if we had a much more precise measurement tool, if we had a much more precise measurement of where the object is throughout the entire thing, it's very likely that both periods would be the same. And that's about it. Thanks for watching.